Today's the day I finally kill you. You don't deserve to live in this world.
You think I will forgive what you did to my family?
I don't care!
It's time to die. No! There must be another way to solve this problem.
You can't stop me! Not now!
Oh no! What's happening to the bullet? The bullet looks like it's starting to melt.
Well done, my student.
Professor, what are you doing here?
I see you have undergone a physics concept beyond your comprehension. So I will explain more in my lecture. Let's go.
Alright, let's go to the lab.
Okay students, so how you imagine that a 20 gram lead is bullet leave a rifle at a temperature of 180 degrees and hit a steel plate. The bullet completely melts upon hitting the steel plates due to high impact from the collision between them. The melting point for the lead is 327 degrees Celsius. So for these questions, let's take notes on the launching speeds of the bullet.
If we want to find the launching speed of the bullet, we first must know what are the energies involved in this situation. So for what we know, the conservation of energy means that the energy in the final equals to energy initial. So for the energy in the initial, firstly the bullet is launched out of the gun. And when the bullet is moving, that means there is kinetic energy involved. And kinetic energy equals to half mv squared. Now for the final energy, there is heat involved since the bullet is melting. So what we have is the Q for mc delta T, which is when the bullet is changing temperatures, and we also have the Q for MLF, which is the bullet changing states from solid to liquid since it's melting. So what we have is the kinetic energy equals to both the heat, and all we have to do to find the launching speed of the bullet is we rearrange the equation until we get V squared equals to 2 times both of the heat.
Well, that is a very good observation. Well, we know that the specific heat capacity for lead bullet is 128 joules per kilogram in Celsius, and the final temperature for the lead to melt is around 327. So the initial temperature, which is originally was 180 Celsius, and the latent heat of fusion is 2.45 times 10 to the power 4 joules. So if we key in the value, we will get the V is equal to square root of 86.632, which is equivalent to 294.33 meters per second. Oh, that's a really fast bullet.
Well done, my students. So how about the impulse delivered to the bullet? As we all know that impulse is equal to Ft, also equal to mv minus mu, or in other words, m bracket v minus u.
So that means, to use this formula of mv minus mu, we know that the mass of the bullet is 20 grams, which we need to change to the SI unit, which is 0.02 kilograms. And we also know that the final velocity when the bullet hits the steel plate is 0. And the initial velocity we already get from the previous question, which is 294.33 meters per second. So that when we substitute in this formula, mv minus mu, we will get the answer negative 5.89 Newton per second. Also, we can say in terms of kg meter per second, because F is force and T is time in the unit N times S, Newton second.
Well done, my students. I think you all understand well about this. So I hope that both of you can settle down your quarrels.
I never thought of that, Professor. Well, thank you for the help. I hope you will forgive me for what I have done.
Well, fortunately, I was wearing a bulletproof vest, so I trust that we have no more grudges.
Oh, thank you, bro. I will see you again.
Bye.